In worldwide hospital pharmacies, highly trained medical professionals are fighting a silent. Every day, pharmacists are forced to handle manual compounding process, repetitive mathematical calculation, and physical paper-based logging. This environment places a cognitive load on healthcare staff. In pediatric care, where the dosage must be calculated down to the milligram based on a child's exact age and weight, the risk of mathematical error is high. When the professionals spend their shift mentally fatigued, navigating cluttered screen and cross-checking inventory sheets, patient safety is compromised, operational overhead rise, and clinical staff face severe professional burnout. Good day to fellow judges. I am Irfan Muhaimin bin Nizamullah from School of Computer Science, Universiti Sains Malaysia. Under the supervision of Dr. Azman Malik, I have spent my major project by analyze, design and build a secure solution to directly address this cognitive crisis. Ladies and gentlemen, I present to you Thedilution. To understand why our solution is highly practicable, we must examine the specific systemic problems that exist in legacy hospital systems today. First, poor UI design. Outdated clinical tools does not guide pharmacists through the preparation process. This enforces users to rely heavily on memory, creating high cognitive load and leading to alert fatigue. Second, data fragmentation. Pharmacy inventory is tracked using a disorganized mix of spreadsheets, physical boards and paper files. This lack of a centralized database that leads to stock shortage and slow administrative audit. Third, there are no automation since hardware are disconnected each other. Compounding machine and hospital software exist as completely separated units. Staff must act as a manual bridge, reading instructions from one computer and walking over to physically press buttons on another. And fourth, local workstation. Traditional pharmacy software is installed only local stationary desktop. It's limiting clinical mobility and delay patient work requests. This project resolved previous problems through 4 technical objectives. First, to build the dilution management system for dosage preparation platform using React. Second, to build a database using MySQL for a data management system in the dilution prototyping machine. Third, to integrate between the data layer from IoT module and AI security module in Node.js environment. And fourth, to apply the system on a server to make it accessible in the hospital environment. Our proposed solution is Thedilution, a secure web-based software ecosystem that automates and digitizes the entire compounding lifecycle. It establishes a secure 3-security handshake. First, doctor can securely submit precise prescription requests from mobile tablets right in the patient wards. Next, pharmacists will verify and approve the request using biometric facial recognition. Once approved, the system automatically runs stock rotation calculation and trigger the physical robotic hardware to compound in real time. The system stability is powered by a robust multi-tier architecture. First of all, at the very top, we have the client layer. Built with the React framework and styled with Bootstrap, this layer acts as system-responsive front-end. Instead of forcing clinical staff to navigate confusing legacy interface, this single-page application provides a clean design. Doctor can request prescription on tablets directly on patient bedside, while pharmacists manage approval on desktop monitors in the laboratory. By executing real-time input validation directly in the browser, the client layer acts as our first line of defense to prevent data entry errors and reduce cognitive load. Next, before requests hit our core business logic, they pass through our proxy and process management layer. Hosted on a secure public virtual private server, we utilize Apache 2 as a reverse proxy. This ensures that all incoming user traffic is securely intercepted, encrypted and safely routed to our internal service. To guarantee high availability and zero downtime for clinical staff, we deploy PM2 as our process manager. PM2 monitors our backend application continuously to ensure that if a server crash occurs, the Node.js environment is restarted automatically in milliseconds without disrupting pharmacy operation. The heart of the dilution lies on application and logic layer that powered by Node.js and Express backend. This layer serves as central integration hub. By using secure JSON Web Token, it validates user session and enforces strict role-based access control. Because of Node.js is natively asynchronous and event-driven, it allows the server to manage multiple background operations simultaneously without freezing the user interface. The system also utilizes Python chat process to generate machine learning script for dynamically calculating stockout forecast whenever inventory is loaded. To secure and manage our relational data, we have data and persistence layer. Here, we run a normalized MySQL database containerized inside the Docker. To bridge our JavaScript backend with our SQL database safely, we utilize the SQLized Object Relational Mapper. SQLized protects the hospital database by automatically sanitizing and parameterizing all queries for neutralizing SQL injection risks. Crucially, this layer enforces strict ACID-compliant transaction. If any step of the medication approval, stock deduction or audit logging fails, the entire transaction is rolled back that guarantee absolute data consistency. Finally, external integration layer, which represent the true commercial strength of this platform. By treating external machine as secure API endpoints, the dilution communicates with physical hardware. During high-risk workflow, the back-end connects directly to an edge computing NVIDIA Jetson Nano camera API to verify user identity using facial recognition. Once biometric approval, the system translates the prescription into a unified format payload and send an automatic HTTP command to a physical compounding robot. This clean integration removes physical barriers that enable seamless automation from digital order to physical compounding. The dilution consists of 5 modules, which is first, user management module, inventory management module, drug control module, job cut handling module, and external system interface. The real-world benefits of the dilution are measurable and impactful. First, zero error accuracy. By automating patient limit checks, the system prevents dosage error before the medicine is prepared. Second, strict database integrity. The system database transactions are fully ACID compliant. If an ingredient is out of stock or the robot is offline, the entire transaction is automatically rolled back to prevent stock data corruption. Third, enhanced workspace mobility. Cloud deployment enables secure access from mobile tablets for reducing communication delay. Additionally, this digital transformation aligns directly with the United Nations Sustainable Development Goals, which is SDG 3 for patient safety, SDG 9 for industrial innovation, and SDG 12 for reducing medical waste. The entrepreneurship opportunity for the dilution. First, the market opportunity. The global pharmacy automation market is a rapidly growing industry. Existing legacy systems are expensive to install. Second, product value. The dilution is designed as a hardware-agnostic middleware. It does not compete with physical robotic compounding manufacturer, but it connects them. By acting as an integration bridge, hospitals can adopt our smart platform without replacing their existing physical hardware, significantly reducing capital expenditure. Third, business model. With business-to-business software as a service subscription model, the dilution is highly scalable, highly secure, and fully ready to be extended for pre-commercialization in private and public healthcare sectors. Fourth, scalability. The system is ready to be extended for pre-commercialization to private hospital network and large compounding centers. Now, let's dive into the dilution system demonstration to see the platform in action. By replacing error-prone manual labor with transactional integrity, real-time communication and smart automation, these systems are not just modernizing the hospital pharmacy. These systems are safeguard the people who work inside it and patients who rely on it. We have built a platform where the modern software engineering meets critical healthcare objectives that ensure a safer, faster and highly scalable future for the pharmaceutical care. Because at the end of the day, we must remember that patient health is our priority. Thank you.